It is one of the most fascinating exoplanets ever discovered by humanity. It has all the conditions to be a new Earth. However, its many mysteries could also make it a bizarre world beyond our imagination, full of surprises, but also potentially our worst nightmare. What secrets does this distant planet hold? And what kind of life might have emerged in its unique environment? Let's embark on a captivating journey of exploration into one of the most mysterious planets in the Milky Way. In 2011, the Kepler Space Telescope made a landmark discovery in its exploration of the universe, a planet located within its parent star's habitable zone, named Kepler22b. The telescope uses an indirect detection method. Whenever a planet passes in front of its parent star, the star's brightness slightly decreases. This tiny change in luminosity becomes evidence of the planet's existence. This method is called the transit method. It not only helps us discover planets, but also allows us to calculate the planet's size, orbital period, distance from its parent star, and even the presence of an atmosphere. Kepler22b's parent star, named Kepler-22, is a yellow dwarf very similar to our Sun, with a roughly comparable size, radius, and age, estimated at about 4 billion years old. However, Kepler-22 is about 20% dimmer than the Sun, so it cannot be seen from Earth with the naked eye. This star is about 635 light-years from Earth, which translates to approximately 3 quadrillion kilometers. Kepler-22b's distance from its parent star is also special. Its orbit is 15% closer than the distance between the Earth and the Sun. If Kepler-22b were in our solar system, its orbit would be between Earth and Venus. In that case, the Sun's intense radiation might have turned it into a hot, desolate world similar to Venus. However, Kepler-22b's situation is completely different from Venus's because its parent star is 25% dimmer than the Sun. Therefore, Kepler-22b receives much less heat than Earth, which makes its temperature potentially similar to Earth's, provided its rotation is similar to ours. If Kepler-22b's axis of rotation is tilted to an extreme degree, almost lying flat on its orbital plane like Uranus, its climate would be very extreme, possibly featuring icy winters and scorching summers. But there is an even more peculiar possibility. The planet might be tidally locked. This means one side always faces the star, while the other side is in perpetual darkness. This uneven distribution of light and heat would lead to extremely unique environmental conditions in different regions of the planet and could determine where life originates and thrives. If Kepler-22b is indeed tidally locked, the side constantly illuminated by light might be the optimal environment for life. Here, the star's eternal light could provide continuous energy, and oceans might regulate the temperature to prevent overheating. Organisms living here might be able to absorb energy through a process similar to photosynthesis on Earth. However, problems would arise. If the planet's surface is covered with water, evaporation on the light side would intensify, creating a greenhouse effect and leading to climate change. This vapor could exert immense pressure on the atmosphere, forming thick clouds and causing violent storms and extreme temperature fluctuations. In such an environment, the survival of complex life forms would become extremely difficult. The challenges for survival here would be immense. If Kepler-22b is indeed tidally locked, the other side would be in perpetual darkness. Imagine, could life exist in this eternal night? At first glance, it seems impossible, but Earth has already proven that life can survive in extreme environments. On the dark side of Kepler-22b, life might rely on chemosynthesis for energy rather than sunlight. Chemosynthesis is the process of releasing energy through chemical reactions. On Earth, many microorganisms have been found in deep-sea hydrothermal vents that survive in a similar way. These microorganisms could form the basis of the dark side's ecosystem, feeding on chemicals gushing from the planet's depths. Furthermore, over time, animals on the dark side might gradually evolve the ability of bioluminescence, using light to attract prey or communicate. In this sunless, dark world, the light emitted by organisms might become key to their survival. Despite this, imagining complex life evolving on the dark side remains a huge challenge. While unique organisms do exist in Earth's polar regions and the deep sea abyss, we have not yet found similar life forms elsewhere in the universe. Therefore, for now, we can only use hypotheses to picture the life in this darkness. Finally, the most fascinating part of Kepler-22b is the twilight zone, the region at the border between the light and dark sides. Scientists believe this could be the most suitable place for life to exist. The temperature in the twilight zone might be stable enough to maintain liquid water, as long as the planet has an atmosphere. In this belt, due to the balance between warmth and cold, bodies of water might remain liquid, forming rivers, lakes, and even oceans. The intense evaporation from the light side and the cooling air currents from the dark side could intertwine here, creating a climate suitable for life. Scientists speculate that the first forms of life might have originated in the twilight zone and then gradually expanded to other regions of Kepler-22b. Just as organisms on Earth can adapt to polar or deep-sea environments, life in this most temperate region might gradually adapt to the extreme regions of light and darkness, evolving unique ways of survival. Although we cannot yet determine the specific conditions on Kepler-22b, the scenario presented by tidal locking offers us rich research opportunities. Whether it's the light side, the dark side, or the twilight zone, each region could hold different potentials for life. However, scientists believe the twilight zone is the most likely place to harbor a complex ecosystem. Future exoplanet research may one day unveil the mysteries of planets like Kepler-22b. Perhaps we will even discover the first extraterrestrial life in this balanced region. This is all contingent on Kepler-22b having an Earth-like atmosphere and a mild greenhouse effect, allowing its surface temperature to remain at a comfortable 22 degrees Celsius. However, it's also possible its atmosphere has a completely different composition, or it might have no atmosphere at all. Without an atmosphere, the surface temperature could drop to -8 degrees Celsius. But if Kepler-22b's atmosphere is like Venus's, filled with dense gases like carbon dioxide, its surface temperature could soar to an unbearable 460 degrees Celsius. Fortunately, studies suggest Kepler-22b might have an ocean that, like Earth's oceans, could help regulate temperature, storing summer heat and distributing it evenly. Scientists also believe Kepler-22b may have abundant water resources, possibly even vast oceans with an average depth of about 180 meters. Although this seems shallow compared to Earth's oceans, remember that Kepler-22b's volume is 2.4 times that of Earth. So if you were to visit this planet, the first challenge would be finding land, which might be much scarcer than on Earth. If you are lucky enough to find land, another challenge is moving around on it. The gravity on Kepler-22b is the second unpleasant surprise. Kepler-22b's volume is about 2.4 times that of Earth, and its mass is 36 times that of Earth. Scientists estimate its gravity would be 6 times stronger than Earth's. If your weight on Earth is about 175 kilograms, then on Kepler-22b, you would weigh 1,050 kilograms. Standing would be nearly impossible, let alone moving. Not to mention the spacesuit you'd be wearing, which typically weighs about 130 kilograms on Earth, would weigh a staggering 780 kilograms on Kepler-22b. Before we can travel to this planet, engineers on Earth would likely need to develop specialized exoskeleton devices to support your back, legs, and arms to alleviate the immense pressure from the gravity. Without this technology, your journey might end the moment you step out of the spacecraft. And don't even think about falling. Even a small depression in the ground could cause you to stumble and fall to your doom. A fall into a 50-meter deep canyon on Kepler-22b would cause you to hit the ground at over 190 kilometers per hour in less than a second, and you would never be able to get back up. Gravity would not only affect you, but all life on Kepler-22b. The plants there would likely be short and stout, with thick, sturdy stems to resist the immense pressure. Despite their limited growth, their leaves and branches would be denser and more compact to reduce damage from the constant gravitational pull. To anchor themselves, the plant's root systems would likely be exceptionally complex and deep. This structure would enhance their resilience, allowing them to maintain their form and survive in a high-gravity environment. The only organisms that might reach a large size would be aquatic algae, as they are more affected by the buoyancy of water and thus less dependent on gravity. However, on this point, scientists cannot be entirely certain if Kepler-22b has oceans, so the composition of the water remains unknown. If water does exist, it would be best to wait until we have a sample and have analyzed it before trying to go for a swim. If you could adapt to life on Kepler-22b and plan to stay long-term, you would also need to prepare for more frequent birthdays. A year on Kepler-22b is only 290 Earth days, much shorter than a year on Earth. But perhaps the most fascinating aspect of exploring this Earth twin planet is the possibility of discovering complex, multicellular life forms. This hypothesis is not unfounded. If Kepler-22b has an atmosphere similar to Earth's and its axial tilt is also similar to Earth's, this would almost guarantee a stable, habitable environment. The planet is located right in the habitable zone, with temperatures not so low as to be covered in ice and not so high as to become a fiery planet. Furthermore, if Kepler-22b does have an ocean, this would further prove it is a planet that could harbor complex life. The most critical question is, if there is life on Kepler-22b, what would it look like? Given the strong gravitational pull, we can assume that life on Kepler-22b has fully adapted to this environment. Similar to the plants, their bodies would not be very large. Instead, they might be like multi-legged reptiles to better distribute their weight for easier movement. These creatures would likely be short, muscular, and sturdy, with powerful limbs specifically designed for walking in a high-gravity environment. Their body structures would also be optimized to minimize energy consumption when moving across complex terrain. To cope with the pressure of the external environment, many species might develop exoskeletons or tough skin. These exoskeletons could be very dense and strong, while also remaining flexible for movement. Their material might be similar to keratin or calcium carbonate, but reinforced to withstand more pressure and stress. The exoskeleton would not only protect these creatures from external harm and predators, but also help them maintain their body shape, preventing deformation under the strong gravity. The exoskeleton might also have a temperature-regulating function, especially if the planet experiences extreme temperature variations. It can be presumed that larger creatures would likely live underwater, where the effects of gravity are reduced. As for flying creatures, due to the strong gravity, they would be almost impossible to find in the skies of Kepler-22b. Nevertheless, these are just models and hypotheses based on theories proposed by astrobiologists and planetary scientists at NASA and other research institutions. Currently, we cannot verify these hypotheses through observation. However, we hope that future technology will allow us to study Kepler-22b in greater depth, perhaps revealing clues as to whether life truly exists there. If the hypotheses about gravity are eventually proven wrong, and Kepler-22b's gravity is only twice that of Earth's, the possibility of human colonization of this planet would greatly increase. In that case, the only major obstacle would be the distance. It is 635 light-years away from us. On a cosmic scale, this distance is insignificant, but from a human perspective, it is almost insurmountable. Currently, the human speed record is held by NASA's Parker Solar Probe. This probe reached a speed of nearly 430,000 kilometers per hour as it approached the Sun, which is equivalent to 119 meters per second. Although this speed seems extremely fast, it is actually only 0.064% of the speed of light. Even at this speed, it would take nearly 992,000 years to travel to Kepler-22b. This is clearly not an ideal option for anyone who doesn't like waiting for an eternity. Therefore, we desperately need a brand new method, and scientists at NASA are working on solving this problem. Experts are exploring propulsion systems based on concepts like nuclear fission and nuclear fusion. These systems could theoretically accelerate a spacecraft to 10% of the speed of light. That would be a considerable speed of 62 million kilometers per hour. Nevertheless, even at this speed, a journey to Kepler-22b would still take 6,350 years. For now, unless we can find a revolutionary method of interstellar travel, colonizing such a distant planet remains an unattainable dream. On Earth, the ability of life to survive and thrive in extreme environments has already proven that even on a seemingly inhospitable planet, life can potentially emerge and flourish. Next, we will turn to other exoplanets discovered by the Kepler telescope, continuing our search for potentially habitable planets. Scientists are searching for terrestrial planets, trying to find Earth's twins, planets that are very similar to our own. The so-called terrestrial planets usually refer to planets with a size similar to Earth's. Such planets have a higher probability of having a solid, rocky surface. Additionally, they must orbit a star similar to the Sun in size and radiation output. The planet must also be within the habitable zone. Kepler-452b was the first terrestrial planet discovered orbiting a Sun-like star. It could be an ideal habitable planet. As early as 2015, scientists considered it the most Earth-like planet discovered to date. The reason for this is that its host star, Kepler-452, is very similar to the Sun. Both are G-type stars with similar temperatures. The only difference is that Kepler-452 is 1.5 billion years older than the Sun. Although this star is slightly brighter and has a slightly larger diameter, the solar energy reaching Kepler-452b is almost the same as the solar energy received by Earth, with only about a 10% difference. Kepler-452b is located within the star's habitable zone at a slightly greater distance, about 1.05 times the distance between Earth and the Sun. Kepler-452b may have a carbon dioxide concentration similar to Earth's. If this is true, it could potentially support life. Since we've raised this question, we can't help but ask, what would it be like if humans could live on this exoplanet? Since Kepler-452b has a greater mass than Earth, its gravity would also be stronger. In such an environment, a person's weight would be much heavier than on Earth, about twice their Earth weight. Initially, humans might encounter difficulties with movement, but over time, the human body would gradually adapt to this new gravitational environment. This provides the conditions for the process of natural evolution to unfold. Humans living in a high-gravity environment for a long time would become stronger. Our bones would become more resilient to withstand the powerful gravity. As generations pass, new babies would be born with stronger physical constitutions than babies born on Earth. However, not all changes would be obvious. Thanks to Kepler-452b's distance from its star, its sunlight and surface temperature would be similar to Earth's. Like on Earth, plants on this planet would also rely on photosynthesis as their primary energy source. Their growth rate and intensity might be similar to Earth's. Scientists also speculate that this planet may have a thick atmosphere, water on its surface, and active volcanoes constantly erupting. If these predictions are confirmed, Kepler-452b is undoubtedly a strong candidate for Earth 2.0. However, this habitable environment may not last long. Researchers believe that in 500 million years, Kepler-452b may suffer from a runaway greenhouse effect, similar to the situation on Venus. An excessive accumulation of carbon dioxide would cause the atmosphere to expand abnormally and temperatures to rise dramatically. Nevertheless, these 500 million years would be enough for humanity to explore and colonize this planet. Kepler-452b is an exciting planet, but it is not the only one in the Kepler series that shows potential. In the universe, there may be many worlds similar to Kepler-452b. Located 500 light-years away in the constellation Cygnus is the Kepler-186 system. There, a red dwarf star is where scientists discovered the first Earth-sized exoplanet orbiting a distant star within the habitable zone. Since then, astronomers have been convinced that there are multiple planets in the universe similar to Earth, with comparable diameters and potentially suitable conditions for liquid water. Kepler-186f's volume is less than 10% larger than Earth's, and its orbital period is 130 days. This alien world is located on the outer edge of the habitable zone, thus receiving only 1/3 of the solar radiation that Earth does, making its environment closer to Mars. However, this difference brings a unique advantage. Red dwarf stars are known for their intense solar flares, which can double a star's brightness in minutes. Despite this, the Kepler-186 star itself is smaller, cooler, and much dimmer than the Sun. Therefore, even with its frequent radiation bursts, Kepler-186b might remain far from these deadly radiation impacts. Whether there is liquid water and the possibility of life on Kepler-186b depends not only on its distance from the star, but also on its atmospheric conditions. Based on the current situation, Kepler-186b's surface might have frozen water. However, its larger size allows the planet to have a denser atmosphere than Earth's. This atmosphere could better retain and distribute heat, potentially keeping water warm. The other 4 planets in the Kepler-186 system are only about half the size of Earth. Their short orbital periods make these planets extremely hot and unsuitable for life. Today, it would take about 780,000 years to reach Kepler-186b. But imagine in the distant future, if we could invent a spacecraft capable of traveling at 90% of the speed of light, then in about 550 years, our descendants might be able to set foot on this planet. So, what would future human exploration be like? Kepler-186, a red dwarf, is smaller than the Sun and about 1/25th as bright. If you were standing on the surface of Kepler-186b at noon, the star's brightness would be similar to the light on Earth an hour before sunset. Scientists say that Kepler-186b maintains a stable axial tilt, allowing it to have regular seasons and a stable climate, similar to Earth. According to calculations, Kepler-186b's axial tilt has remained stable for tens of millions of years. This stability is crucial because if a planet's axial tilt is unstable, its climate conditions would change drastically, making it uninhabitable. For example, Mars may have experienced extreme climate shifts due to the instability of its axial tilt, eventually becoming the desolate landscape it is today. In 2020, Kepler-1649c was unexpectedly discovered while reviewing past observation data. It was initially misidentified as a false positive. We still know very little about Kepler-1649c, especially its atmospheric composition. But since Kepler-1649c receives about 75% of the sunlight Earth does, and its orbital period is only 19.5 days, its temperature could be similar to Earth's. If Kepler-1649c has no greenhouse effect atmosphere, its surface temperature would reach -38 degrees Fahrenheit. Although this temperature seems unfriendly, Earth would also face near-zero Fahrenheit temperatures without greenhouse gases. Even if the atmospheric compositions of the 2 planets were similar, Kepler-1649c would still need more greenhouse gases to make up for the difference. There are many other Earth-like worlds in the universe, with striking similarities to Earth in terms of both temperature and size. For example, TRAPPIST-1f, TRAPPIST-1d, Teegarden Star C, and TUI 700d. These exoplanets are relatively close to us. However, reaching Kepler-1649c still seems out of reach. Spanning a distance of 470,000 light-years makes it seem untouchable. However, if one day we could cross these vast star-filled skies and embark on a hopeful journey, this destination would be worth it. Because these nearby planets cannot compare to the unique combination that Kepler-1649c possesses. Kepler-1649c is not only potentially similar to Earth in temperature and size, but it is also located right in the habitable zone, making it a truly extraordinary discovery. With the advent of next-generation astronomical observation facilities, we will obtain more clues about whether these planets are habitable. At the same time, we will continue to explore another impressive celestial body located about 1,100 light-years away in the constellation Lyra, Kepler-442b. It orbits a K-type star every 112 days and is about half the distance from its star as Earth is from the Sun. Such a close distance could pose a threat to any potential life forms on the planet. Typically, planets orbiting close to their stars become tidally locked, which can lead to extremely harsh surface environments. However, Kepler-442b is located at a greater distance from its star, which keeps it far from the range of being tidally locked. K-type stars are dimmer than the Sun. The Kepler-442 star itself is smaller and cooler, so Kepler-442b's environment is in a relatively ideal state, at a distance of about 0.4 astronomical units from its star. Scientists believe that K-type stars represent an ideal balance in the search for habitable planets. Although they are not as bright as giant stars and do not have the long lifespans of M-type red dwarfs, they offer very favorable conditions. Within 100 light-years of our Sun, there are at least 1,000 K-type stars. The lifespan of these orange dwarfs can be as long as 15 to 45 billion years. In comparison, our Sun has a lifespan of only about 10 billion years, and at the end of its life, Earth will no longer be habitable. Astronomers often classify planets based on their potential habitability. The updated Habitability Comparison Index is more comprehensive than previous methods. It evaluates a planet's habitability by considering multiple factors. This index not only focuses on the planet's composition, with a particular preference for rocky planets, but also considers the eccentricity of the planet's orbit, as orbital eccentricity affects the stability of the light and heat the planet receives from its star. In addition, the Habitability Comparison Index also incorporates albedo, a measure of the solar energy reflected by the planet's atmosphere. The Habitability Comparison Index ranges from 0 to 1, with higher values indicating greater habitability potential. In both of these indices, Kepler-442b has been given a score of about 0.84. However, unfortunately, this exoplanet is too dim and too small to be directly imaged with current telescopes, let alone for interstellar travel. Even the fastest space probe would need 1.7 million years to reach Kepler-442b. What we can do now is study its biosphere. A study once analyzed the radiation levels of potentially habitable exoplanets, and Kepler-442b stood out. It receives almost enough sunlight to support a significant biosphere, which could potentially be detected by the Webb Space Telescope. As the Webb Telescope further observes this planet, we might also hope that it will turn its gaze to two other interesting exoplanets in the same constellation. These two planets are located in the Kepler-62 system. The other three planets in the Kepler-62 system are too close to the star, causing their surface temperatures to be too high for life. Scientists are particularly interested in Kepler-62e and Kepler-62f because these two planets may be water-rich worlds. Their Earth similarity indices are 0.83 and 0.69, respectively. Kepler-62e has an orbital period of 122 days, while Kepler-62f's orbital period is 267 days. Kepler-62e is believed to be covered by thick clouds, and its climate is generally warm and humid, even extending to the polar regions. This climatic condition makes it an extremely suitable environment for life. A 2014 study proposed that Kepler-62e might have a large moon. If this hypothesis is correct, the planet's chances of being a habitable world would further increase. This is because large moons are crucial for the evolution of complex life. Through tidal forces, they can help regulate a planet's rotation and axial tilt, thereby directly influencing its climate patterns. Moons can also provide a protective shield, deflecting or absorbing impacts from asteroids or comets, thus protecting the planet and its life. Although the more distant Kepler-62f has a lower surface temperature, it may still be habitable. However, even if this hypothesis is correct, considering the lack of metals, elements crucial for technological advancement, it seems unimaginable for a highly advanced civilization to form on this planet. However, the complexity of nature still exists. Perhaps creatures more creative than us could emerge, capable of surpassing our technological achievements in other ways. Perhaps they could even survive underwater. If humanity decided to send a message via the Parker Solar Probe to any intelligent alien life that might inhabit these strange worlds, they might receive the message, but it would take at least 1.85 million years. However, if we send a radio signal today, it would reach these two exoplanets in 1,200 years. On the grand cosmic scale, this is but a fleeting moment. Although Kepler-62e and Kepler-62f are not currently ideal Earth twins, the ever-changing nature of planetary systems means that these planets may undergo transformations. Our planet was once completely covered by oceans, but over a long period, it gradually evolved into a diverse world with both land and oceans. Researchers are contemplating the future evolution of these exoplanets, speculating that they might eventually transform into Earth-like environments, forming a harmonious coexistence between vast land masses and oceans. Meanwhile, if life does exist on these exoplanets, they might be very complex and highly intelligent. One of the biggest challenges in studying distant planets is the immense distances between them. However, we may not have to wait for ultra-high-tech telescopes to solve this problem. Data from the Kepler mission and the European Space Agency show that half of all Sun-like stars may have potentially habitable rocky planets, and some of these systems may be in our cosmic neighborhood. This means there is at least a 95% probability that an Earth twin is hidden within 20 light-years of us.